Section 6.4, Addition, Subtraction, and More Multiplication. So like radicals have the same index and radicand. They're just alike. And remember that 3x plus 5x, those are like terms. So one way to think about it is that we can factor the x out, the common factor of x. That leaves us with 3 plus 5. 3 plus 5 is 8x. So that's one way to think about it. You have 3x plus 5x, you have 3 of them, plus 5 of them, you have 8 of them. Notice that the x is in the original problem and the x is in the answer. I like to think of it as 3 apples plus 5 apples is 8 apples. So they're still apples. So similarly, we can add 3 times the square root of 2 plus 5 times the square root of 2. So if you want to think about the square root of 2 as a common factor, if we factor that square root of 2 out, what are we left with? 3 plus 5. And 3 plus 5 is 8, so we have 8 square root of 2. So it's just like the previous problem, only x is the square root of 2. So we have like radicals. 3 square root of 2 plus 5 square root of 2 is 8 square root of 2. So to add or subtract, we simplify by collecting like radicals if possible. So 11 square root of 10 minus 5 square root of 10. You have 11 of them minus 5 of them. You are left with 6 of them. 2 cubed root of 9 plus 6 cubed root of 9. They are both cubed root of 9. The radicand is the same and the index is the same. So 2 of them plus 6 of them, you have 8 of them, and they're still cubed root of 9. Sometimes we need to simplify radicals by factoring before adding. Add or subtract, and simplify by collecting like radicals if possible. So this first example, we have the square root of 28. Now 28 is 4 times 7. So that's the square root of 4 times the square root of 7. Square root of 4 is 2, square root of 7. 63 is 9 times 7. So it's the square root of 9 times the square root of 7. The square root of 9 is 3 times the square root of 7. Now look at that. We have like radicals. They both have square root of 7. 2 of them plus 3 of them, you now have 5 of them. Square root of 12 minus the square root of 3. Remember that 12 is 4 times 3, so we can make that the square root of 4 times the square root of 3. What is the square root of 4? 2. You cannot take the square root of 3, so it stays under the radical. So 2 radical 3 minus radical 3. 2 of them minus 1 of them. You have 1 left, so it's radical 3. 5 times the cubed root of 16 minus 3 times the cubed root of 54. The cubed root of 16, you can't do that. But 16, what factor of 16 can you take the cubed root of? It's 8 times 2, and the cubed root of 8 is 2. Multiply that by the 2 that's already out there. You cannot take the cubed root of 2, so it has to stay under the radical. Cubed root of 54, what can we take the cubed root of? We can take the cubed root of 27, and 54 is 27 times 2. So, what is the cubed root of 27? 3. We cannot take the cubed root of 2, so it stays under the radical. So we have 10 of them minus 3 of them. 10 minus 3 is 7, so we have 7 of those cubed root of 2's. That's our solution. So we had to simplify each radical before we could combine the like terms. What about this one? 4 square root of 3 minus 3 square root of 2. Before, we've had like terms. There are no like terms or like radicals here. So, it is through. You cannot simplify this. That's all you can do. Just notice that there are no like radicals. Let's do more multiplication. This is distributive property. We've got the square root of 3 times the square root of 2. That's the square root of 6. Minus the square root of 3 times the square root of 3. That's the square root of 9. Square root of 6 you can't do anything with, but the square root of 9 is 3. And that's it. You cannot combine those. One has a radical, one does not. The cubed root of x times the cubed root of x squared. We want to multiply using the distributive property. So the cubed root of x times the cubed root of x squared is the cubed root of x cubed. 5 times the cubed root of x. I'm putting the 5 first so we'll avoid the problem of knowing if the 5 is under the radical or not. So what is the cubed root of x cubed? That's just x. We have no like terms here. One has a cubed root of x, the other has just the x. So we have to stop. Look at this one. How do we handle a problem like this? A binomial times a binomial, we FOIL. First, outside, inside, last. So, first, square root of 2 times the square root of 2. I'm going to write that out just so we'll make sure we know what we're doing. So the outside is plus square root of 2 times the square root of 3. Inside is minus square root of 3 square root of 2. Last is minus square root of 3 square root of 3. So square root of 2 square root of 2 is the square root of 4. Square root of 4 is 2. Square root of 2 square root of 3 is the square root of 6. Minus square root of 3 square root of 2, square root of 6. Look at those. Plus square root of 6, minus square root of 6. Those guys cancel each other out. Minus the square root of 9. The square root of 9 is 3, so it's minus 3. So our final answer is 1. Take a moment to enjoy the amazing situation we have here. I never thought when I looked at this, look at that mess. The square root of 2 minus the square root of 3 times the square root of 2 plus the square root of 3. You took something that hideously awful and you got as the answer 1. What a lovely problem. I wonder if this one will turn out so well. So we have to FOIL it again. So 2 times 4 is 8. Minus 2 times square root of 6. That's outside. Inside plus 4 square root of 6. And last, minus square root of 6 times the square root of 6 is square root of 36. So we have 8. These guys are like terms. 2 of them plus minus 2 of them plus 4 of them. That gives us 2 square root of 6. Minus the square root of 36 is 6. These are like terms. 8 minus 6 is 2 plus 2 square root of 6. And that's our final answer. We can't combine those. One has a radical, one does not. That's all for section 6.4.